Okay, so I have at least half of you that already have the documents. I'm guessing the rest of you are still getting around to it. I'm going to start with the material for the day by just doing a little review on what we started doing last Thursday. So last time we talked about the difference between a sample and a population. We said there's different ways of choosing samples, and then based on the sample that I have, how it was chosen, whether it was biased or unbiased, then I could determine whether my results were better or worse, right? So the problem that you have on the board is just in order to get started again on thinking about what a sample and a population are, right? So for example, in the first case, you have okay, so what we need to do is to determine for each one of the two studies that you have over here what the sample is going to be, what the population is, and what the sample size is in each one of these cases. The first case you have, among all Americans, American adults aged 18 years old or more, and the percentage who use the following media sites are as follows, right? So 58% use Facebook, 23% use LinkedIn, 22% use Pinterest, 21% use Instagram, and 19% use Twitter. Now, according to you, what is the population for this study? Okay, everybody can lower their hands now. And I'm going to assume that when somebody has their hands up, it's because they want to answer the question. And if nobody wants to answer the question, I will choose somebody at random to answer the question. Okay, yes, so the population is going to be American adults of, so that means American people with 18 years old or more, right? So American adults, right? Then the sample is what? What is my sample in this case? Andres?
I'm not sure.
Okay, so the sample in this case is going to be what? Is it a sample of adults, of teenagers? Is it a sample of all women, all men? What is it?
Well, it's a sample of adults who use
Okay.
the social media. Okay,
a sample of adults, not necessarily that use social media. Okay, so this is just a sample of adults, so some amount of people that use or don't use social media. We don't know that yet. What we want to do, if our sample is representative, is determine actually the number of people that use social media, right? So eventually we will get to those conclusions. Does everybody understand that? Yeah, so then what you have is a survey that was conducted among a certain number of adults. How many adults, how many people are in my sample? Based on this one.
It's 2003, I think.
2003, right? And that's because we have the n is equal to 2003. So that means that my sample size is going to be 2003 people. If you understand, please raise your hand. Okay, good. Lots of hands up. That's really good. All right, for the next one, we have a survey that was conducted in which people answer the question, why, like, what is a reason to get married? And it is segregated among the people that are married or the people that are unmarried. So some of them say love, some of them say making a lifelong commitment, then companionship, having children, or financial stability. The population in this case is what? Okay.
The people who are married.
The people who are married or
Unmarried.
or unmarried, right? So you have a certain population of people, and you want to determine whether like what the reasons that they consider to be reasons to get married are going to be, right? So like this is either married or unmarried people. And so the sample is also a sample of married and unmarried people, right? So you have, like here it says, asked of married and unmarried separately. So that means the data was collected between married and unmarried people as well. It's just that there's fewer people in the sample than in the population, right? So married or unmarried people as well. And how many people are in the sample?
I got 2,691.
2,691. How did you get that answer?
I just added the number of people that they surveyed who were married and then the number of people that they surveyed that were unmarried.
That's exactly right. So like this is 1,306, which were the married people, plus 1,386, which were the unmarried people, and then the sample size is the total between the two, right? So you have a total sample of married and unmarried people. So what we have is essentially a population that we want to study. In the first case, American adults. In the second case, married and unmarried people. A second part here is to determine the sample. So in order to study this population, we're going to select a given sample. Here, there's no information given on how that sample was chosen, but it was chosen nonetheless. And so the sample should be chosen to be representative individuals of the given population. And then the sample size can vary depending on the number of resources that you have, the size of the population that you actually want to study, and so on. So, right, so this is the idea. Yeah, so sorry, Ulrika makes a good point. So wouldn't the population be people in general and then sample married or unmarried, because that's how we distinguish them? Yeah, so here the population, I say married and unmarried people, which basically covers all the people. But the reason that I want to specify married and unmarried is that part of the study, part of what the study is trying to do is to compare between these two pieces of the population, right? So you want to actually make a distinction, which is why the samples were chosen independently for married people and unmarried people. Yeah. Do I have any questions about this? Yeah, so in this case, it would be known from the beginning because it's assumed that the researchers in this case actually want to determine what the differences in these opinions are going to be between married and unmarried people, right? So in order to determine this, they need to make sure that they are actually surveying enough married people and enough unmarried people. Right, so this is like from the beginning, they have determined that this is two sides of the population that they want to compare, and then they choose their sample based on that information. Okay, so we're going to go back to the statement that we had last time. So we talked about for today's teens, friendships can start digitally, not digitally. For today's teens, friendships can start digitally, and we said 57% of teens have met new friends online. We found a different percentage for our class. The margin of error is plus or minus 3.7 percentage points, and social media and online gameplay are the most common digital venues for meeting friends. So this is what we talked about last time. Now, while we were discussing this, we ended up with three conclusions about the statements that we had over here. The first thing that we said is that 57% was just an approximation, right? So that this didn't mean that necessarily in North America or in the US or in Canada, you would have that exactly 57% of teenagers met people online, but you had that approximately this value should be true, right? So that if we were to look at the whole population, the value for the whole population should be somewhere close to 57%. So that means that 57% is an approximation of the proportion in North America. Right, so this is the conclusion that we reached. We said this is an approximation. We can't know for sure if this is the right proportion or the proportion for the whole population of North America, or if it's something a little bit different from 57%. We also said that if we were to choose a different sample, we would most likely get a result that would be slightly different. Maybe not exactly 57%, but maybe 58%, maybe 60%, maybe 53%. So I shouldn't expect to get the exact same result if I were to choose a sample, even if that new sample had exactly the same size, right? And that might happen just because of random chance. So a sample is different, like a new sample would be different from this sample, not necessarily because it gives me different information, but just because there's some randomness that comes with choosing a sample, and so I should expect a different estimation, right? So a different sample will most likely give a slightly different estimation or approximation. Can I see a show of hands for those of you who understand why this is the case? Okay, so I have 12 hands up. If there's any questions, you can go ahead and interrupt me. And then the last thing that we said last time was also that if we were to choose a larger sample, so we said, okay, this seems to be a pretty trustworthy estimate, but if I wanted to make sure to have an even better estimate, then what I should do is just make my sample a little bit larger, right? So if I made my sample larger, then that would mean that I have more information that I'm considering, and so I should have a better estimate, right? So if we had a way to choose good, so I specify good because it's not enough for it to be for the sample to be larger. It also has to be a good quality sample, so a representative sample and everything we talked about last time. If we had a way to choose a good larger sample, we would probably get a better approximation of the proportion of teenagers that meet friends, friends online in North America. All right, so if my sample were a little bit larger, then I should expect my estimation to be slightly better. Show of hands for those of you who understand this. All right, that's good. Now, we've been talking a little bit about population versus sample, so we're going to elaborate on that conversation by looking at the following example. So in the example that I'm going to give, okay, so we're going to keep working with the teenagers, the number of teenagers that meet friends online. And what we have is that we start with a given population that we want to study, right? So the whole point over here is that we start with the population that we want to study and with a question that we would like to answer. So we have a population that we want to study and a question that we would like to answer, right? Now, what we said last time is, okay, we start with this question, but we don't necessarily have the resources in order to collect information from my whole population over here. So if I wanted to interview every single person in my population, then I would have a lot of trouble trying to interview every single person, right? I wouldn't have the resources, I wouldn't have the time, it wouldn't be feasible, and so on. So instead, what we end up doing is we select a sample and we ask a similar question now from the sample. So in this case, that means that we're going to ask a similar question. So what proportion of the teenagers have met someone online? But we are going to ask that from the sample instead, right? And so what we have is a question over here that we want to answer. And what we end up doing is we create a question for a sample that will help us answer this question for the population. Gemma, there's a question? Oh no, okay, so there's still 4 people with their hands up. That's Rafael, Kyle, Alexi, and Gemma. You can lower your hands, that would be ideal. Okay, so we end up with this question, and then we can actually collect some data from the sample and try to answer the question. So what we said last time was that if we collected data from our sample, we had found that from here, our proportion of teenagers that met somebody online was equal to 0.57 or 57%, right? And here I'm going to put a little hat on that proportion because this proportion is not the proportion for the whole population, but rather the proportion for the sample. And so it's just an estimator of the proportion from the population. Right? So what this gives me is the proportion, what I have here is the proportion of teenagers in the sample who met someone online. Right? And so what this is a measure that I can compute based on my sample. Now, the reason that I want to summarize my sample through a number like this is that now from here I can conclude, or I can say, okay, well, this seems to suggest that the proportion of teenagers in the population who met someone online is going to be somewhere close to that number, right? So that means that if I look at the proportion of teenagers that have met someone online, should be some number that is going to be, I mean, I don't know if exactly 0.57, this is going to be P, but it's going to be maybe 0.57. We're going to put it with question marks over here because we don't know if this is a proper estimation, but it's the best guess that we can make. Does everybody understand why this is the best guess? If so, please raise your hand. Okay. So here's the thing. When we're talking about this proportion, this is a characteristic of the population and it is a value that is fixed. And what we're trying to do with this number over here, which is a summary of the sample, is to estimate this thing over here, right? So we have a measure that summarizes the sample. And from that measure, we're trying to guess what the corresponding measure is for the population. So what we're going to talk about in this case, so the way that we're going to refer to this number is a statistic. So we're going to say that a statistic is a value that summarizes a sample. Okay. And correspondingly, if we're talking about the same kind of concept, but now for a population, what we're going to say is that a parameter is a value that summarizes the population. Right? So a statistic is a value that summarizes a sample. A parameter is a value that summarizes the population. Raise your hand if you understand this. Okay, good. Now, the thing about a statistic is that a statistic depends on the sample. And because a statistic depends on the sample, that means that this is going to be actually random. So the value of a statistic is random because it depends on the sample that you choose, right? So the value of the statistic is random because it depends on the sample that you choose. Right? And so depending on the sample that you get, you're going to get a different value for the statistic. The parameter, on the other hand, is fixed because if you have a population that is fixed at any given time, then you have that the value of, let's say, the proportion of teenagers that have met friends online at a specific time is going to be fixed. Okay, so I know that every day somebody new becomes a teenager and somebody stops being a teenager, and that's true. But we're assuming that we're looking at a snapshot in time, and we're trying to determine what the value for the proportion of the population is at that snapshot. Okay, so on the other hand, we have that the value of a parameter is fixed. Okay, we could even say it's almost theoretical, right? Because since we're talking about like a snapshot in time, which is not a realistic scenario, we're trying to actually determine something that's theoretical, that is fixed, and that we have no way of actually determining. Okay. So in this case, our statistic is the proportion, the estimation for the proportion of the sample. This is So this is our statistic. And for the population, this is my parameter. And keep in mind that here, I have no way of knowing what the actual parameter is, right? So I only have, the parameter is always going to be for us kind of this idea, the thing that we're trying to estimate, whereas the statistic is our actual estimator, so the thing that we're actually computing from the sample. And from here, I can say the big statement for today, which is that, a statistic is a value computed from a sample to estimate the value of a parameter. Okay? Do I have any questions from this, or does everybody understand? Can I see a show of hands for those of you who understand everything that I've been rambling about today? Okay, that's pretty good. So then, whenever I'm talking about a statistic, I'm going to be referring to the thing that refers to the sample. And when I'm talking about a parameter, I'm going to be talking about the idea of the thing that we want to study. Again, a parameter, we're never going to know what the value of the parameter is, okay? Because that's the whole point. You're trying to get information, but you can't get information for the whole population. So you'll never know what the parameter is. So whenever I ask you, what is the parameter? You're just giving me the definition of what you're looking for. So for example, in this case, my statistic is 0.57, and the parameter is the proportion of teenagers in the population that have met someone online, right? So parameter will end up being a kind of philosophical idea, whereas the statistic is going to be an actual number, right? If you want to remember, which one is a parameter, which one is a statistic, fairly easy. Population goes with parameter, P and P, and sample goes with statistic, so S and S. Okay, so population parameter, sample statistic. Okay, so to just practice a little bit about the idea of what a statistic and a parameter are, we're going to do an activity. Can please, everyone that has finished taking notes from this slide, please raise their hands virtually. Because I know that a couple of you mentioned that I was going fast between slides. Okay, so I have Jenny and Roshan. All right, okay, so I think we're good. All right, so I'm going to put a new activity on the board. And in this new activity, what I want you to do is you have 4 scenarios, so 4 studies, and you need to identify the population, the sample, so who was interviewed, who was the data collected on, the parameter that we're interested in, again, just like the idea, what are we looking to estimate, and then the statistics by which we are estimating that parameter, okay? Questions? No questions? I'm looking at the chat. I'm looking at if there's anybody with their hands up for a question. Okay. All right, so if there's no questions, you'll have, maybe I'll give you about 9 minutes until 12:10 to work on this problem. I'm going to ask everybody to unmute their mics. So I've asked you all to unmute them. If you can, please do so. And then actually maybe in like 7 minutes, I'll give the answers. And that will move forward faster. Yeah, 7 minutes to work on this. Population sample parameter statistic. Okay, so let's start talking about this. For the first example, so we have a poll is a type of survey that is used to make statistical inference, a conclusion about a population based on a sample, right? So that's kind of what we've been talking about. In 2013, Gallup, a polling agency, surveyed 2,048 adults to find out Americans' main source of news. 55% of adults responded that they get their news from television. So, what is the population in this case? I will start randomly assigning people if I get no answers.
American adults.
Population is American adults. And the sample is also going to be a sample of American adults, right? So it looks like the sample, based on the statement that 55% of adults responded that, blah, blah, the sample is also adults in the US, right? Then, what is the sample size over here, just to make sure that we have that on hand?
2048.
2048. And then we get to the part that's actually new for the data, right? So we need to determine what the parameter of interest is. So what is the parameter of interest in this case?
Is it 55%?
So 55% is something that is computed based on the sample, right? So that's actually going to be our statistic. Okay, so our statistic is going to be 55%, which is the sample percentage of adults that get their news from television. Okay, so that's the statistic, which means the estimator. According to you, what is the parameter? Is anybody confident about their choice for what the parameter is?
People who get their news from television.
Yes, so it's going to be the proportion of people, so of US adults, that get their news from TV, right? So as I said before, but maybe like in a concrete situation, it's a bit easier to see. The parameter is an idea, whereas the statistic is an actual number. Okay, so the statistic we can compute, the parameter we can just think about. For the next one, we have, in 2009, Time Magazine conducted an internet poll of affluent adults, people whose income is $150,000 per year or more. A total of 603 affluent adults over the age of 18 were interviewed. And they found that 95% of them made online purchases in the last year. So, population. There's a population here. Anyone? Who are we interested in studying here?
Adults
Adults that what?
are affluent.
That are affluent, which means earn more than 150,000 per year, right? So that's my population. These are the people that I'm trying to study. Oops, this is 1.5 million. That's not what it is. Yeah. Then a total of 603 affluent adults over the age of 18 were interviewed, which means that that's going to be my sample, right? So my sample is going to be 603 affluent adults over the age of 18. Then I have my parameter. What is the parameter that I'm trying to estimate here? Or maybe what is the statistic that I have here?
95%.
95%. 95% corresponds to the proportion of what?
That made online purchases.
Yes, so proportion of affluent adults, that made online purchases. So proportion of affluent adults in the sample. So I'm going to write sample proportion of affluent adults that made online purchases, which means that the parameter is this same proportion, but for the population, right? So this is the proportion of all affluent adults that make online purchases. Okay. Now look at the difference here. So the proportion is the proportion of all affluent adults that make, as a general statement, online purchases, whereas the statistic is the sample proportion of those that have made online purchases, right? And that's because that's the data that we're collecting. So trying to look at the principle of everything that happens, whereas the statistic is measuring something that actually occurs. Okay, third example, we have in 2013, an article published by The Guardian, an English newspaper, a survey found that 62% of 16 to 24-year-olds prefer print books over digital books. In this survey, 1,420 young adults aged between 16 and 24 were interviewed. So, population.
Young adults.
Young adults. Right, between the ages of 16 and 24. Sample.
1,420 young adults.
Young adults. Young adults. The parameter.
The proportion of young adults who prefer print books over digital.
That's right. So proportion of young adults that prefer print over digital. And then the sample is the corresponding proportion, the statistic is the corresponding proportion for the sample, right? So the sample proportion for the same thing. I'm just going to put ... which in this case turned out to be 62%. Right? So that's our estimation for the proportion in the population. And finally, we have the CDC, Center for Disease Control, collected data from 20,015 Americans between 2007 and 2010, wanting to know what the typical height of women over age 20 was. 5,971 women aged 20 and over were part of the study. They found that the average height in centimeters was, that doesn't make any sense, in inches, was 63.8. So what is the population in this case?
American women.
American women over the age of 20, right? So specifically.
Okay.
Because they want to know the typical height of a woman over the age of 20. So that's the target population, which is why the sample is chosen in this way. Then the sample is the number of women that we chose, which were how many?
20,015.
Okay, so here be careful. What is my population?
American women over 20.
Yes, and so my sample needs to be the sample that corresponds to the American women over 20. So what is that going to be?
5,971.
5,971. Because what I have is a sample of all of the Americans, but if I'm studying here just women over 20, then I need to look at a sample that only that's only made of women over 20, right? So that's going to be the 5,971 women over 20. Then we have the parameter that we want to estimate. What is the thing that we are trying to estimate in this case? What do we want to determine? Maybe this, average, no? Or the mean height of women over 20. And so the statistic by which we're going to evaluate this is going to be the sample mean or sample average for the height of women over 20. And so this is going to be 63.8 inches, which is the sample average height of women over the age of 20. Does everybody understand this? So this is the average that I evaluated for the sample. All right, can I see a show of hands of those of you who understand what we've been doing so far?